A function f is represented verbally by square the input x and then subtract 5. Give symbolic, numerical, and graphical representations of f. Let x equal -3, -2, -1, all the way through 3 in the numerical representation, the table, and let -3 is less than or equal to x is less than or equal to 3 for the graph. So let's start with reminding that it's square input x and subtract 5. And we want to write the symbolic version of that, or symbolic representation. So we would start with f of x, and that equals square x, and then subtract 5. So f of x equals x squared minus 5. For the numerical representation, we have a table of values, and here are the x values that we're going to apply the function. So it's square the input, so square -3, and that would be 9. Subtract 5, and that's 4. Now we square -2, that's 4. Subtract 5, and that's -1. For -1, we square it, that's +1, subtract 5, and that's -4. Substituting in 0 for x, we square it, and then subtract 5, so that's -5. Then we begin to repeat, actually. 1 squared is 1, subtract 5 is -4. 2 squared is 4 minus 5 is -1. And then 3 squared is 9, subtract 5 is 4. So here is our numerical representation. And now for the graphical representation. Remember, we were asked to keep x between -3 and +3. However, we just finished the numerical portion, so I've rewritten the values of the numerical table in vertical form rather than horizontal form. And these are the ordered pairs we'll use to graph this function. -3, 4. So -3, 4. -2, -1. -2, -1. -1, -4. And then 0, -5. Now we start on the other side, the positive x values. We have 1, -4, so that's going to be here. 2, -1, and that would be here. And you might begin to see that we have symmetry going on here. So, of course, 3, 4 would be the point up here. And so to draw our graph, we simply need to connect those points with a smooth curve, which of course is the shape of a parabola. And this is the graph of f of x equals x squared minus 5.